Hello and welcome to this webinar highlighting the results from the PISA 2015 assessment of students' ability to solve problems collaboratively. Andreas Schleicher, Director of the OECD Directorate for Education and Skills, will present the key findings of the assessment. After his presentation, Andreas will be joined by Jeffrey Moe, who led the team of analysts that produced the report, to answer your questions. Please feel free to send your questions at any time during the presentation, and you can do that by clicking on the question mark at the right of your screen. Also, the PowerPoint that Andreas will be presenting is available as a handout, so just click on Handout to download the PowerPoint. Now to the results. Andreas?
Yes, hello. This is a great day for PISA. It's the first time that we have been able to assess some aspects of social skills in the assessment in the form of collaborative problem solving. Now you may ask, well, what this entails exactly and why we do this. Let me start with the why. We do know that social skills play an increasingly important role in the modern world, in life and at work. We have seen, for example, that skills that we call routine cognitive skills are on the decline, whereas social skills, the capacity of people to collaborate, compete, and connect, is actually on the rise in the modern world. So you ask yourself, how did we actually measure collaborative problem-solving skills? And the way we did this in the context of a large-scale assessment is by basically having students interact with a set of digitized agents, like what they would do in some modern computer games. And so this was a kind of simulated collaborative environment, very engaging for students. You might still wonder to what extent does this represent the kind of human-to-human interaction that really makes sort of collaboration. And to answer this, we actually took a small sample of students and put them to work together in a digitized environment, but also in a classroom. And we looked at their results, we compared them to this approach, we found they were quite similar. We even found that teachers' judgments on students' social skills were quite in line with what we measured through PISA, so we're quite comfortable that this represents a reasonably valid representation of human-to-human collaboration when it comes to the kind of collaborative problem-solving skills that we were setting out to measure. You see that here on the screen. On the horizontal dimension, on the horizontal axis, you see the competencies that we're looking into. For example, whether students were able to establish and maintain and share understanding of a problem. Each of them had different pieces of information, and together they were asked to sort of figure out what the nature of the problem was. We were looking into whether they could take an appropriate strategy and action to solve the problem, and also whether they were able to establish and maintain the team even when there are disruptions and kind of problems that they were encountering. And we looked at a specific set of problem-solving processes where students could actually deal with it. So this was the kind of collaborative problem-solving that we assessed in PISA, and again, the digitized environment that we used proved to be a fair representation of how humans would solve those kinds of problems. Now, let's get to the results. What we found is that there was some relationship between academic skills and collaborative problem-solving skills, and you'll be not surprised by this, because if you want to solve problems, you have to be able to process information, you have to do some calculations, deal with numbers, and so on. So there was some relationship. But the relationship was actually far weaker than what you would see, for example, in terms of the correlation between reading and numeracy skills, for example. In fact, we found that individual skills, science, math, or reading, explain less than 2/3 of the variation in student performance on this collaborative problem-solving scale. We also found, and that's very interesting, that some countries that did quite well in the assessment of individual skills came out even better on the collaborative problem-solving skill. Let me highlight a few examples. Japan. Japan was already a strong performer on PISA and science and math and so on, but the Japanese 15-year-olds did even better when it came to social skills. Singapore is another example. Top performer in math, top performer in science, and still they were, relatively speaking, even stronger on the social dimension. True also for Korea. United States is an interesting case. They did not do so well on PISA, just sort of so-so on the PISA scale, but when it comes to social skills, collaborative problem solving, American students come into the kind of high performers area. So relatively speaking, American students also do far better than they do on individual skills. Now, there were also some countries that did less well than you would expect from their academic skills. Chinese students, they came out really well when it comes to, you know, science and math, but they did only so-so when it comes to social skills. The Russian Federation also did better in science and math than they came out here, and the same holds for Turkey and Montenegro and a few other countries. So for individuals and nations, it's quite clear that individual skills don't provide a guarantee that social skills also develop. Here's a more systematic view of looking at this. You can see the blue bars going up, telling you that performance in collaborative problem solving is relatively stronger compared with country performance in reading, math, and science. Now you can see again, Japan, Australia, United States are countries that did better in collaborative problem solving than what you would predict from their performance in reading, math, and science. Then you had some countries in yellow where there was not much of a difference, and then countries in red where you can actually see that they did not come out so well on the social dimension than on the individual dimension of skills. So first important finding is that social skills are not an automatic byproduct of, you know, academic skills. And vice versa, you know, having great social skills doesn't guarantee those kinds of academic skills. Let's get to the next question. You know, in relative terms, you could see countries on this list, but let's have a look at absolute performance. What is it actually that students were able to do? And that's where we were actually quite surprised. You know, when you look at the performance tasks at level 4, what we asked students was basically to, you know, engage in tasks that were cognitively quite easy, but involved a fair amount of collaboration complexity, where they had to maintain awareness of group dynamics, sort of see what other students are doing, and take also some initiatives to resolve some problems or conflicts. Now, that doesn't sound very difficult. In fact, when you look at some of the tasks, you'll see, you know, how could anyone get those things wrong? But we found actually only 8% of students were able to reach that level 4, and even in the top performer Singapore, it's only about 1 in 5. So in absolute terms, development of social skills doesn't seem to be one of the real strengths of school systems. Now, you compare that with the very high complexity and difficulty of tasks in math and science that, you know, performance at the highest level would involve, and you'd actually, you know, sometimes you have a hard time getting those tasks right, but these looked like simple tasks, but many 15-year-olds had great difficulties with this. Even at the baseline level, you know, you had a fair number of students who can at best complete tasks with low difficulty, limited collaboration or no collaboration complexity, and typically what students in this share of the distribution did, that they focused just on their own role, and so on. So basically, in absolute term, probably most countries could make a lot of headway in getting better results. We also found that there are important gender differences. And interestingly, they go in the other direction than gender differences on individual skills. For example, in 2012, we assessed creative problem-solving skills for individuals. And we found that boys consistently did better, at least in most countries. Well, in this round, when we looked at collaborative problem-solving skills, girls outperform boys in each and every country. And in fact, not just outperform. In most countries, the difference is really large. Now you talk about, in some countries, 30, 40 score points on PISA, and on most scales, you know, 30, 35 points is the equivalent of a school year. So these differences are fairly large. You may still wonder to what extent what you see here is simply a reflection, you know, of girls also doing better in reading. But, you know, we have looked into this. On this chart, now you see basically the gender differences after considering student performance in science, reading, and math. So this is basically the advantage of girls that is really unique to collaborative problem solving. And you can see it's almost the same. Slightly less, but almost the same. So basically, there's a huge advantage that girls have on social skills, whereas on individual problem solving, it used to be the other way around. Now, there is this gender gap in every country, but in absolute terms, as you can see here, in some countries, you look, for example, Singaporean boys still outperform the girls in the majority of countries. So keep that in mind. There's room for improvement for both boys and girls on this scale when you look at this across countries, despite the big advantage that girls really have. Now, what's interesting is that the gender differences in performance seem to be also reflected in attitudes towards collaboration. As always, PISA collects a lot of contextual data from students. And we found that girls tend to report more positive attitudes towards relationships. They tend to be interested in others' opinion. They want others to succeed. Boys, in contrast, were more likely to see the instrumental benefit of teamwork and how collaboration can help them work more effectively and more efficiently. Have a look at some of those results. Here you see exactly what I just mentioned to you. Now, for example, girls were more likely to say, I'm a good listener. I enjoy seeing my classmates be successful. I take into account what others are interested in. I enjoy considering different perspectives. On the other hand, boys were more likely to say, I prefer working as part of a team. I find that teams make better decisions than individuals. I find that teamwork raises my own efficiency. At first hand, you might say, well, aren't those really very similar questions? But actually, on second thoughts, they're not. The first really value the nature of collaboration, working with others, being part, the kind of empathic component of collaboration. The second basically just see collaboration as a means to an end. And that makes a difference. You can see that in the next kind of slide. Basically, first of all, those attitudes vary across countries too. You can see here, for example, when we summarize all of the questions concerning relationships, now you can see that overall girls are stronger on this than boys in their attitudes, but those figures vary hugely across countries. You look, for example, on the right-hand side, Singapore students do not do only well, but boys and girls also tend to value the kind of relational aspects. On the left hand of the slide, you can see basically systems where that kind of value is not so pronounced. That was about valuing relationships. Now let's have a look at valuing teamwork. And you can see the gender pattern is reversed. Now the boys come out higher, the girls come out lower. And again, there are important differences across countries on this. Now, attitudes, do they matter? Well, let's have a look at attitudes towards collaboration and how performance pattern looks like. Here you can see some interesting results. We could basically see that attitudes towards collaboration were often an important predictor of collaborative problem-solving skills relative to what we saw in math, science, and reading. For example, when students said, I'm a good listener, they tended to do better. When they said, I take into account what other students say, they were more likely to do better on the PISA assessment. So basically, positive attitudes towards collaboration also tend to be reflected in better relative collaborative problem-solving skills. And the differences are significant. What's interesting, this is not simply a reflection of social background. Even after accounting for, whether, for the gender and also for the students in school socio-economic profile, you could see that this pattern still prevails. So attitudes and performance go together. What the causal nature of that relationship, that's something we can't answer with these kinds of data. This also varies by countries. For example, taking into account others' interests. Now, remember, that was one of the dimensions of valuing relationships. And you could see again, in most countries, is a quite good predictor of better performance on the collaborative problem-solving scale. Not everywhere, but in many countries. Finding that teams make better decisions, that was one of the teamwork dimensions. And you can see again, where students have that kind of attitude, you could see that they did better in relative performance on the collaborative problem-solving scale in a large number of countries. So attitudes and performance go together on balance, but also in the majority of countries. Now, the question, of course, is what can learning environments do to shape attitudes and outcomes? And we looked at this in quite some detail. Let me share a couple of interesting results. First of all, the first thought you might have when you think about collaboration in school, is about physical exercise. No? Students doing sports, they work together, they play together, there's a kind of interactive sports, it's a kind of team activity, much more so than what you might expect for mathematics or reading or language class. No? And in fact, what you can see is the more frequently students exercise moderate physical activity, the more positive their attitudes towards valuing relationships was. And that was true for boys in green and for girls in yellow. When they sort of made more vigorous physical activity, their pattern is a little bit less clear. But still, you can see there is a quite important relationship between the physical activity, the frequency, and the extent to which students say they value relationships. You can also see the same for teamwork. Now again, you can see moderate physical activity and even vigorous physical activity in this case tends to be related to a more positive attitudes towards teamwork. For boys, now on top, and for girls, a little bit lower, but with the same kind of pattern. Now, lines are not straight, there are exceptions, but overall, that's the pattern that we observe. In a nutshell, more frequent physical exercise relates to more positive attitudes towards teamwork and also relationships. But it gets more interesting. Now, truancy. Now, whether students, for example, you could see where students said they were skipping a whole class, typically they reported a more negative attitudes towards relationships. Where they skipped some classes, same thing. Where they arrived late for school, same thing. And on the teamwork dimension, skipping a whole school tended to be also negatively related to a positive attitudes to teamwork, skipping classes, arriving late for school, same story. Now you might say, well, that might be entangled with socio-economic background, basic disadvantaged students putting less of a premium on relationship and also coming late to school. But actually, when you take that out, the pattern remains pretty much the same. So actually, we look at a kind of, again, what it suggests if schools become better in engaging students, in having them valuing the kind of collaborative work, maybe that may also induce them to be less truant if the causal nature of that relationship goes in this direction. Now it gets more interesting when you actually look at not just physical exercise where it seems obvious, but also interaction in science classes. For example, when we found that students were given opportunities to explain their ideas, spend time in the laboratory, carrying out practical experiments, were asked to argue about science questions. So the more interaction there was in the science class, the more positive the attitudes were. Where students did well on this, where basically they said, where they said there was a more interactive engagement in science class, you could see that they were more likely to say, I'm a good listener, I enjoy seeing my classmates be successful, I take into account what others are interested in, I enjoy considering different perspectives, I prefer working as part of a team, I find that teams make better decisions, I find that teamwork raises my own efficiency. So on virtually every dimension of student attitudes towards relationship, we found that kind of positive association between engagement, interactivity in the science class, and attitude. So this suggests, again, to the extent that is a causal relationship that where teachers succeed, to create a more open, engaging, interactive environment that induces more collaboration. It may also frame more positive attitudes towards collaboration. Now, one of the things that we found really interesting is when you disaggregate this by social background, we actually found that students from wealthier home backgrounds tended to value relationships more, whereas disadvantaged students are more likely to value teamwork the instrumental value of collaboration. Actually, this is an association that it was not us to find first. There's a lot of research on this in the literature that suggests that, students from, more privileged backgrounds see more the kind of empathic overall value in relationship, whereas students from disadvantaged backgrounds see themselves, better taken care of in a kind of team. So that is not something that is new, but it's striking that the pattern is quite consistent also in PISA. Advantaged students more likely to value relationships, disadvantaged students more likely to value teamwork. You can also see that, across countries on individual indicators. This is basically an indicator of teachers' discipline. We asked to what extent the teacher had ever, been very harshly criticizing students in front of their classmates. And you can really see that that is a quite, negative predictor of collaborative problem-solving skills. Even, both at the student level, that's the blue dot, but also in some countries at the school level. So in some schools, there seems to be a more harsh kind of climate, and that seems to be associated with more negative student learning outcomes at that school level. So disciplinary climate seems to be a predictor of relative performance in collaborative problem solving. And again, when I talk about relative performance, that's performance after you take into account student achievement in math, science, and reading, sort of the unique component. We see a similar factor, when students feel threatened by other students, sort of bullying. Now you can see in most countries, students score higher when they reported that had not been threatened by other students. And you can see that at the individual level, but you can also see in many countries this happening at the school level. So there being a climate of bullying in school being associated with lower performance at that school level. So again, when you see those relationships at the school level, that always suggests, that's something that policy or school environment or the socio-economic environment really can engage with. This leads me to another interesting question. One of the biggest challenges facing teachers, at least that's what teachers tell us in our teacher survey every time, is diversity in classrooms. Engaging with increasingly diverse student needs, student interests, and backgrounds, and so on. But what we found, actually, that the kind of greater diversity can actually be associated with better relative performance in collaborative problem solving. You can see here, for example, the performance differences between the top and bottom quarters of the concentration of immigrant students in school, sort of what's the relative share of immigrant students. And you can see in some countries, there's a big advantage actually of schools that are more heterogeneous. And even on average across OECD countries, there's a small but significant benefit of diversity in terms of fostering relative advantage that students have in social skills. So it's an interesting finding. Diversity doesn't seem to be a drag, but seems to be an asset when it comes to the relative strengths of students in collaborative problem solving. That may be because more diverse students may sort of be more inclined to collaborate with students who are different from them. The last point that I want to really make is that for this kind of set of indicators, it's also important to look beyond the school walls. Basically, what we found that only about 1/4 of the performance variation among the student population lies between schools. When you look at basically the differences that students show in their performance on the collaborative problem-solving scale, most of that is differences that you see within schools. Only about 1/4 really lies between schools, and that's a lot less than what we found, for example, in reading, in mathematics, and science. What to read in this is not so clear. It could mean that, for collaborative problem-solving skills, social skills, what happens out of school plays a very important role. It could also be that there's just less variability in the kind of school policies and practices than you would find in mathematics or science classes. Now, there are many reasons that explain this, but the bottom line is that the challenge of fostering collaborative problem-solving skills is largely one that you have to address in almost any school, in every school, as opposed to just pick a few schools that are not doing well and then fixing them. That's true maybe in countries on the left side of the scale, countries like Israel, Bulgaria, Hungary, and so on, but it's certainly not true in the middle and particularly not to the right end of the scale. Basically, you can see, for example, in countries like Iceland, Finland, Norway, or even Spain, there's almost no variability in collaborative problem solving among schools. Schools do quite similar, but within schools, you find a lot of variation. We also found that the strengths of the relationship between the social background of students and performance on collaborative problem solving, here the abbreviation CPS, basically is much less pronounced than what you find in science, reading, and mathematics. In other words, if you know the social background of the student, it's much harder to predict their performance in collaborative problem solving than is the case in science, reading, and mathematics. Again, that's interesting. Social background does not seem to be such a barrier for students from disadvantaged backgrounds to do relatively well than it is the case in mathematics, science, and reading. Again, you could hypothesize that's because, there's lots of things out of school that strengthens the social skills, or it could be that simply schools are better to mediate the impact of social background. For example, by engaging students from disadvantaged background more in kind of collaborative initiatives. Either way is possible. We also looked at technology, and the findings here are such that basically what happens outside the classroom, at home, in the case of video games, had a clearly negative impact on collaborative problem-solving skills. Now, students who play video games tend to score lower in collaborative problem-solving skills, particularly when you don't discount social background. After discounting, the gap gets much smaller, but it's still significant. But you can't deduce from that digital devices are negative. For example, where students were chatting or pursuing social networks on the internet, that actually tended to have a positive impact before and even after accounting for social background. So it's not just the frequency of internet use at home, but also about the nature. Video games, and that's actually, some people might say, well, video games are a social initiative, students playing with each other and so on, but it doesn't seem to be conducive to social problem solving skills, whereas in engaging with other people, chatting, social networks seem to be more on the positive side. Now that's out of the school. We also looked at this in school. And we asked, to what extent, what's the intensity of technology used at school? And here you find a pattern where you can actually see the students, the schools that use technology most intensively were actually the lowest performing schools in collaborative problem solving. That's the blue dot. And schools at the bottom quadrant, now you use technology least, were doing fairly well. But the best performing schools were typically the ones that used technology a little bit, sort of in the second quarter of the distribution. This is actually something that we have also found in other domains. We looked at this quite carefully in the case of mathematics in 2012. We also find this kind of curvilinear relationship, where there is no technology use, schools and students did not do so well. When the use was moderate, we could see sort of more positive outcomes. And then when the use of technology got intensive, outcomes turned again the other way around. It is very hard to interpret those data. Some say, well, technology detracts from social interaction or even from learning. But other people say it's simply that we are not yet very good at using technology effectively. Because in principle, technology should offer us the possibility for precisely the kind of things that I mentioned, more interactivity in the classroom, virtual laboratories, social learning, collaborative learning. All of those things can be very much enhanced with technology, but the bottom line is that's not what we see in the data. Current use of technology does not seem to be conducive to better performance before and even after accounting for social background. The last point, parents also have an important role to play. Look at this. the simple fact whether students talk to parents after school, no, and had a very important positive relationship to learning outcomes in collaborative problem solving, both at the student level, but in many countries also at the school level, where you had a school where there was a climate where parents were more engaged in the student learning with their children. No? There, the school results tended to be better. That's what you see in the orange bar. So this is an important finding because, you know, showing your child that you're doing well in school, or engaging you that what the child is doing is important to you, is something that is not very difficult to do. It doesn't take a lot of time, but in fact, it does seem to be something that predicts better outcome. So parents clearly have a very important role. So in summary, strong academic skills don't automatically translate into strong social skills, and vice versa. This requires a deliberate effort. We've also seen that some countries do so much better in collaborative problem solving than what you would predict from their science, mathematics, or reading performance, and some countries do worse. In absolute terms, we've seen that only 8% of students can solve the tasks at level 4, where the collaboration complexity is fairly high, and even in top performer Singapore, it's just 1 in 5. We've seen that boys did better in individual problem solving, in 2012, but girls do better in collaborative problem solving in every country. And also gender differences in collaborative problem solving seem to be mirrored in the attitudes towards collaboration. Girls showing more positive value of relationships, where boys put greater emphasis on teamwork. We have also seen that there are important relationships between the learning environments and the attitudes to collaboration and collaborative skills. Remember, the more interactive the science lesson was, the more students were engaged in sort of activity there, the more positive their attitudes towards collaboration. And again, collaboration seems to be related to skills. We've seen that disadvantaged students see the value of teamwork often more clearly than their privileged peers, and also that exposure to diversity tends to be positively related with collaboration skills once you net out performance in the other domains. Frequent playing of video games relates negatively to collaborative problem solving, but internet use, chatting, social networks do not. What do we take away from this? Well, you know, you could see in the case of sports, there's a lot you can do to foster positive attitudes towards collaboration, but also, you know, in a science class, there seem to be ways to engage students in a way that relate to more positive attitudes. So there seem to be opportunities across the entire curriculum to foster collaboration. We've also seen, we can also say that fostering more positive relationships at school and also designing learning environments that benefit students' collaborative problem-solving skills and their attitudes towards collaboration can be a positive thing. Giving students more control and ownership over the time, place, path, pace, and interactions of the learning. Now, remember, the more interactive, engaging the science class was, the more responsibility there was on students, the more positive the attitudes. It's also possible that enhancing social activities that foster the kind of positive and constructive relationships and also school attachment can be important. Maybe teacher training on classroom management. Remember the kind of negative impact that punitive kind of teacher disciplinary measures have on attitudes towards collaboration. And obviously, you know, the findings on bullying are quite concerning. And they show that a whole of school approach to preventing and addressing bullying is really important. And last but not least, fostering parental engagement. With that, I will stop to leave you enough time for questions. Thank you very much.
Thank you very much, Andreas. Yes, we do have a few questions that came in. The first one, a listener from Turkey asked, does PISA examine the association between the profile of a school's student population and that school's success in the collaborative problem-solving assessment?
Sorry, I could not hear that question well. The student, PISA, sorry?
Sorry, yes, I'll repeat the question. 1 second. A listener from Turkey asked us, does PISA examine an association between the profile of the student population in a school and that school's success in collaborative problem solving? In other words, does the characteristics of the student body have an impact or is an association with whether the school performs well in collaborative problem solving?
Yes, exactly. In fact, in the charts where you could see a blue dot and an orange bar, that's exactly what the chart shows, whether there is an aggregate effect at the school level. Now, what that profile exactly involves is something that we would need to look into more detail, but in principle, the data allow this. But you could see in a number of countries, it's in fact the aggregate kind of composition of the student body that has the important relationship, not just the individual relationship.
Thank you. Another question, were there country-level effects of GDP or other economic factors on collaborative problem-solving skills?
Yes, you do find them, like for any of the other skills, but again, you know, they explain a few percentage point of the performance differences among countries. In fact, it's not, you know, the world is no longer divided between rich countries that do well on collaborative problem solving and poor countries that do poorly on this. In fact, the variability that we see between students, between schools, is much greater than the variability that we see between countries, and particularly when you look at accounting for GDP.
Thank you. On the issue of physical activity, someone asked, what about China? Don't students there tend to have more physical activities on average than many other students, and yet they don't seem to be scoring particularly high on the collaborative problem-solving assessment? Is there some kind of a strange association there?
Well, actually, that's a very interesting question. I can only offer hypotheses. First of all, you know, the relationship between physical activity and attitudes is mainly one with attitudes. But also when you look actually at sports lesson in China, they are rarely one of team sport. Mostly you see students standing next to each other doing kind of gymnastics. You actually don't see the kind of, you know, team activity that you would, you know, sort of intuitively associate with a more positive attitude towards collaboration. But again, whether this is an explanation for the relatively lower performance of the Chinese students, I can't say.
Okay. I have a rather technical question here that came in, so I think I might tap Jeffrey Moe, who is here with us, who is an analyst here at the OECD, who has led the team responsible for this report. Jeffrey, someone asked us how we calculated the influence of socioeconomic status and so on collaborative problem-solving skills. Was it by linear regression? The reason the person asked is they were wondering whether it was possible that the difference between valuing relationships and valuing teamwork is a residue, and it might be a self-enhancing effect. This is what this person was asking. Could you explain a little bit about how these kinds of differences and the influences of various factors were calculated?
Sure. So in the end, we did use a linear regression to calculate the influence of socioeconomic status on a variety of outcomes, and this includes the performance in collaborative problem solving, the relative performance in collaborative problem solving, and also the attitudes, so valuing relationships and valuing teamwork. I'm not quite sure what you mean by whether this is residue or whether the valuing relationships, valuing teamwork is a residue. If you mean by that ESCS or our socioeconomic status affects performance through attitudes. Yes, we looked at that. We also ran simultaneous regressions over both attitudes and socioeconomic status, and the results are robust.
Great, thank you, Jeff. And we also have got several questions about concerning the issue of playing video games. either Jeff or Andreas, could you please describe a little bit about the questionnaire about video games? Was there a differentiation made between different kinds of games? Perhaps there is a difference if you play multiplayer or single-player games, and if the game is a strategic or an adventure game. And does the data differ depending upon what kind of games we're talking about? Also, whether these are played socially, collaboratively, online, or whatever. I leave it to either one of you. Jeff, do you want to start maybe?
Actually, no, we don't have any resolution to that extent. We just ask very general questions about video games. I think the questions that this listener poses are very relevant. We might well see differential effects by different types of video games, but simply we've looked at the intensity of video games per se only here.
Thank you, Andreas. Another question, how different is the collaborative problem-solving assessment than the problem-solving assessment that PISA conducted in 2012? Was there a separate assessment and questionnaire, or did they use the similar questionnaire?
No, actually the test was quite different. I would say that the cognitive demand of the collaborative problem-solving assessment is much lower. Like the individual problem-solving tasks that we posed to students in 2012 were actually quite difficult, but they were tasks which students had to solve individually. Whereas in 2015, we focused really on their capacity to engage with others, to identify shared problems, to find solution strategies and collaboration, and to pursue those solutions in interaction. That was the focus of 2015, not the cognitive demand in terms of problem-solving skills. So the scales are quite different and the results are quite different. You could see that there's a broad relation among the two, but there are countries that do better on collaborative problem solving than they do on individual problem solving. You could also see that while boys do better on individual problem solving, girls do better on collaborative problem solving. So the instruments were quite different in their orientation and the results are quite different too.
We also have a question here from someone from Brazil who wants to know, who finds or notes that Brazil is one of the worst countries in collaborative problem solving, and this person wants to know how can Brazil improve their score in collaborative problem solving.
Yeah, you can see that on the first slide that I showed, actually, that country performance really varies quite a lot. And the first thing I would say is that an important prerequisite for performance on collaborative problem solving is actually to equip students with solid foundation skills, where students do not have basic literacy and numeracy skills. They're going to have a hard time also collaborating, because collaboration always means sharing information, developing solution strategies, and so on. So when you look at a country like Brazil, probably your best bet to do better on collaborative problem solving is really to engage with kind of foundation skills. And yet you can design even there, as you could see in science and math, much of the learning that goes on could be designed in a more collaborative fashion. So which could be a way to foster collaborative skills next to academic skills, but also in a country like Brazil, engage students from disadvantaged backgrounds, because you could see that seems to be easier on the collaborative problem solving domain than when we look at more kind of traditional assessments.
Thank you. We have a question from Moldova as well. This person was wondering if are there any covariations between teachers' gender and collaborative problem-solving performance?
Interesting question. We haven't studied that in this report, but it's certainly something that is worth looking into. The difficulty why we can't really answer this so well with PISA is because we're only looking at one age group, one teacher or a group of teachers of that age group. Typically, you would expect that the entire gender range that of teachers that students have had might have had an impact on their skills, and we just don't have that in the survey. But I think it's an interesting question.
Jeff, one of our listeners was wondering whether we have any data about the role or the relationship between artistic education, music or dance activities, for example, or theater activities, and collaborative skills?
We don't have data on, per se, artistic education, so dance class, music class, art class in the questionnaire itself. So we can't relate such classes to collaborative problem-solving skills. However, what we do have are the availability of such activities in extracurricular activities, for instance. So whether schools offer a band, orchestra, or choir outside of normal academic classes. And what we found was that students who attend such schools also tend to be of a higher socioeconomic status. And we know that socioeconomic status is related to higher performance in collaborative problem solving. But if we look at just the effects on the collaborative skills, the skills that are unique to collaborative problem solving, we find that there's actually no association with the availability of these extracurricular activities. But that being said, we don't know which students in a school attend such activities outside of school hours.
Thanks, Jeff. Andreas, one of our listeners also was wondering if you could recommend to the policymakers of Europe in particular, but I guess this could be really applicable around the world, how education systems can help students develop their social skills. What kind of education policies would be most effective in this way?
You know, that's always hard to deduce from data like this, but overall, what I would argue is that, you know, given the increasing demand on social skills for people, the performance of most school systems, including high performers on the scale, is still very modest. Sort of students, 15-year-olds, seem to have difficulty with even relatively basic kind of collaborative tasks. So the question is, you know, how can we raise all boats on this? And there are several avenues that this survey illustrates. You know, one is obviously, you know, out of school, the whole world out of school can make a difference. Physical activity is something, you know, having social activities in school can play a role. But I would also argue that designing more innovative learning environments that are more engaging, that give students more control over the pace, the pace, the time, and of their learning, and make learning a more engaging exercise for students in collaboration with others, is probably something we need to look into this. You know, we ask students to be collaborative. Now we expect them to be collaborative when they enter the workplace, but in school, we put them behind individual desks, and at the end of the year, we give them an individual test. Now, that doesn't really well align with the demands of the modern world. So I do think really this result suggests that we should think harder about how do we design innovative learning environments that combine high levels of academic skills with high levels of collaborative skills. Now, the fact that one doesn't need to detract from the other is perfectly illustrated by countries like, you know, Singapore or Japan. You know, I'm here in Singapore this week, and I've seen classrooms here where you can really see they are very creative in designing innovative learning environments where students have a lot of room to take responsibility for activities, interact with others in a math class, in a science class, so not just in, you know, sports or physical activity. So I do think there's significant scope for policy to be more creative in thinking how we better align the skilled needs of tomorrow's world with what we do in school.
Thank you. Another question asks whether there was any attempt to link the problem-solving scales of 2012 and 2015 at any level. Were there any shared items between these two tests at all?
No, because again, the tests had a very different goal. If we would have embedded, you know, tasks from the 2012 individual problem-solving scale in the kind of collaborative testing environment, we would have probably made them far too difficult. So that was not the goal. We really wanted to look at the collaborative dimension, but without making the tasks cognitively too difficult. That would have confounded those two aspects. What you can do is you can basically, you know, do a cross-tabulation of countries, how they come out on individual problem-solving skills and collaborative problem-solving skills, and that cross-tabulation is in our book.
And something else that we did did do between the two assessments was that the framework for the problem-solving aspect of the assessments was the same. So even as Andreas said, what we used in the collaborative problem-solving assessment required a lower level of difficulty of the problem-solving elements. They had the same type of elements, so in terms of representing and formulating the problem, for instance, or in terms of trying to actually solve the problem. The different steps that are involved in solving a problem are the same in the two assessments.
Thanks, both of you. Another question, which either of you are welcome to answer: are there any interesting trends within the different types of collaborative problem solving? Did you notice anything trend-wise that of interest?
Well, actually, these were aspects that we have measured so far only once. In 2012, the individual problem-solving skills, in 2015, the collaborative problem-solving skills. So it's only going to be possible forward to actually look at trends. In fact, I should also say social skills, this was the very first time that we were technically able to do this. We have been working on this test for many years, but it's only proved possible in the context of the 2015 assessment to design an assessment instrument that was so kind of flexible that we could test those kinds of interactive skills.
Thanks. And another participant just asked if you could share with us a little bit in more detail about how students actually took this test. Could you kind of describe what it was like for these students, how they encountered their quote-unquote teammates, and in relative to that, another participant asked what the subset of human-to-human students that you looked at when they to determine whether or not this was a reliable way of assessing students. How large that sample was. So if you could just talk a little bit about both how we came to the conclusion that this was a reliable way to measure student collaboration, and how exactly students were asked to interact with their quote-unquote teammates.
Yeah, for example, in the book you find one example unit that we basically sort of portrayed. Students were told the teacher has divided the class into different teams, and they were in a contest, and so you had to sort of work with your teammates on answering questions about a specific country, explore a country, based on the geography, with the people and the economy, and then it started like posing different questions. Basically, the digital agent would basically propose a strategy, and then somebody else would be saying something else, and then you had to moderate and find some common ground on, first of all, what the nature of the problem is. So it was quite interactive, where you constantly had to respond to questions and proposals from your teammates and align them. That was the nature of the task, but you can see that in detail in the book. And in terms of the validation exercise, Jeff, you want to say a few words about that?
Sure. So the validation study that we commissioned looked at whether human-human interactions could be faithfully proxied by the human-computer interactions that we used in the collaborative problem-solving assessment. And what they did they did a couple of things in the validation study. Firstly, they reformatted some of the items in order to replace one of the computer agents with a human agent, so another student essentially. The first time, in one of these exercises, you had the students sitting in separate locations. They didn't see each other. They didn't know whether they were interacting with another human or a computer. And what they found out was that the results from their assessment were actually very, very similar to their results using computer agents. In other words, the reformatted units and the original units gave very similar results. Any differences were small, and performance in the two assessments was highly correlated, so that performance in the units that we use in the assessment, the human-computer ones, are still very faithfully informative of the performance that you would observe between humans and other humans. Something else that Something else that we examined was, or that the validation study examined, sorry, was whether teachers' opinions of their students' collaboration abilities tallied up with the results of their performance in the CPS assessment. These teachers have been working with their students for the entire year, and therefore you would think that they would know roughly how their students perform, or to have a better idea, have a better insight into how well their students work in groups. And it was found that yes, teachers' opinions of their students' performance in collaborative problem solving was very well correlated with the performance that you observed from the human-computer interactions used in the assessment. Finally, some other units were reformatted so that students work side by side, face to face, trying to resolve a collaborative problem. And the results that they obtained were looked at, and they were also observed by trained markers. And it was found that their performance there was also moderately well correlated with the performance in the human-computer units. So therefore, we have three pieces of evidence that show that human-computer performance, what we measure with this assessment, is a faithful proxy of, and is informative of, the performance that you would see between humans and humans in real life.
Great, thanks very much, Jeff. I think we have time for only one more question. So I received this from another listener. Andreas, you cited the relationship between classroom interaction and collaborative problem-solving performance, but there is probably quite a lot of variation in how science classes, for example, are structured in different schools and in different countries. What can we take away from these results as far as how countries or how education systems should structure their classroom interactions, particularly given the collaborative problem-solving assessment as it was used in PISA?
Yeah, it's absolutely true that kind of classroom designs and instructional designs vary hugely within across countries, but there are a few common patterns that we can really observe. And that is where students had more room to ask questions, to explore things, to be in a laboratory, to explain their own work to their fellow students and so on. Where those things happened more frequently, attitudes and performance in collaboration tended to be more positive. So these were sort of common patterns that we observed and that we surveyed students on. That being said, of course, there are so many different ways how you can teach science that need to be taken into account.
Great, thank you very much, and thank you all of our listeners for your very interesting questions and your interest in our work, in OECD's work on education in general and in PISA in particular. We invite you, in fact, to visit the PISA website at www.oecd.org/PISA, where you'll find this report on collaborative problem-solving assessment, as well as the first 4 volumes of the PISA 2015 results. You'll also find current and archived issues of PISA in Focus, data visualizations, videos about PISA, and information about this and forthcoming webinars. This webinar has been recorded and will be available in a couple of days on our website, www.oecd.org/PISA/webinars. Once again, thank you very much for joining us, and we hope to see you or hear from you next time.